All right, so we're going to be getting into modeling stairs. How do we go about modeling the stairs? But before we can learn how to model them, we have to learn how to build the stairs. And this gets a bit tricky because it includes math. And math is always a challenge for most people, and stairs are a little bit tricky. So in this tutorial, I just want to cover the basic kind of fundamentals of how we go about building stairs, and then we're going to go ahead and build the actual stair or just the riser and the treads um, for our two-story residence in this tutorial. Okay. So first, I'm going to start off by actually just turning off a lot of this stuff that we don't need. So it's going to be the roofs. I don't need to see the windows. I don't need, let's see, I don't need the doors. I really don't even need the second floor. Let's turn that off, right? We are going to need, oops, no, 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 turn that off. We are going to need the actual floor itself because what we're trying to do is get from this floor, from the top surface of this floor up to the top surface of that floor. Okay. All right. So first of all, how do we go about building stairs? Well, before we figure that out, we have to understand that a stair is composed of a tread and a riser. The tread is where you put your foot on. The riser is where you put is the actual kind of height of that stair. Okay. Now we follow a code or we follow a ratio called the 7-11. Okay. 7-11 is the ideal kind of step. If we, or I should say, we have all realized or we've all walked through those steps that are less than 7 inches, right? They're like 3 inches or 4 inches. And everyone finds them to be very annoying, very frustrating. But what's interesting is that we all notice the difference, right? The minute that a step is not 7 inches or like the average height, we all immediately notice that, wait a minute, something is off here, right? And so that's because by code, or yeah, by code, steps are all, they all have a 7 inch max height. So we all try to get as close as we can to 7 inches without passing 7 inches. If we go anything noticeably lower than 7 inches, like 5 inches, then that's when people start getting upset at us. There is a reason for that. Sometimes we want to slow traffic. Sometimes we don't want people to kind of slow down. Um, when they're going up the steps, sometimes we want a much slower, gradual rise, but that becomes a design move, and that's up to, the designer. But for this case, we're going to stick to a 7-11. Okay. Now, you might think, well, okay, if everything is 7 inches, then let's just make every riser 7 inches. The problem is that most of the time, our distance from the first floor up to the second floor never breaks up evenly into 7 inches. And this is where that annoying math comes into play, right? So if we were to, I'm going to go ahead and move this over here. If we were to take the 7 inches and copy it up, we've now gone 14 inches, right? Now, one of the parts that a lot of um, people who are just starting off with risers forget is the tread. Because now not only have we gone up 14 inches, we are now using up 22 inches. And by the time we add the third step, we've now gone 33 inches, right? Now, the same with the treads. We do not want to go anything less than 11 inches. Okay, so riser is 7 inch max, the tread is 11 inch minimum. There is some wiggle room on the building code. There are some exceptions where you can go 10 inches. And the same with the riser. There are some exceptions where you could go 8 inches, but you have to go into the building code and find those exceptions. But most of the time, we don't want to go less than 11 inches. Now, the tread can go longer. It could go 12 inches or 14, 18, 20 inches, right? It could be however long we want. It just has to be a minimum of 11 inches. So back to my point. The more steps we add, the higher we're going, but the more space the more length we're also taking up. Okay. And that is also where people get kind of confused because they only give themselves, say, 8 feet of length to go 9 feet up. And you could see that if we were to go 8 feet, that's about right here, we're not going to make it. We're not going to make it all the way up, right? So, how do we go about doing this math? Well, we know that the height is 9 feet, right? The floor to floor height is 9 feet. So if I pull up my calculator, okay, we know the floor to floor height is 9 feet, and we know each riser we'll start off with 7 inches. So there's the first part, or the first part that complicates it is that we need to convert feet into inches, right? Because if we're going to go up 7 inches, I can say we need 10 steps. That's going to give me 70 inches. But what is that in feet? Are we at 9 feet yet? We don't know. So we need to convert feet to inches first. So the way we do that is we multiply our feet by 12, right? 1 foot is equal to 12 inches. 2 feet is equal to 24 inches. So 2 times 12 is 24. So if we go 9 times 12, that gives us 108 inches. So we know we need to go 108 inches up. Well, we could divide that by 7 because that's our lucky number. So divide that by 7 gives us 15.43 steps, right? So so what do we do then? If we go 7 inches and it goes up 15 feet, or if we put 15 steps, we're going to be short, okay? Let's look at that. I'm a visual learner. Let's see what does that actually look like. So I have 3 steps here. I'm going to copy, and we're also going to learn a cool little copy trick here. I'm going to go from one corner to the next corner, right? But up here, we have all these other options. It says, do you want to use the last direction? Yes. So now I'm continuing in that direction. Do you want to use the last distance? Yeah, because we're going to be making multiples. And do you want to go from the last point? In other words, do you want to go from this point to this point? Then from the last point is from here to there, right? This would be our last point. And I'm going to say yes. So now with all of these yes, I can just click, 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 click. So I have 1, 2, 3, 4. So 5, 6, 7, 8, 9, 10, 11, 12, 12, 13, 14, oh, 15, and hit enter. Right. I didn't have to go endpoint to endpoint to endpoint. I can just move my cursor in the direction and click, 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 click. Okay. So here I have 15 steps. And there you can see that I'm short. Now, if I was to add another step, say 16 steps, I'm over, right? If I was to make each one of these steps just a hair taller so that it adds itself up. So let's say if we go, I don't know, a 1/4 inch on every single step, well, then we would eventually, I don't know if a 1/4 inch would be it, but we could figure out that math. Then we would get flush right there. But if we add anything to each riser, then we're exceeding the 7 inches max, right? So we can't add. So what we have to do is we're going to have to add one entire step so that we're over and then make each one a little bit less than 7 inches, okay? So the trick to remember, or the thing to remember, is that whenever we do the math and we end up with anything over our whole number, so 15.4, even if it's 15.1, we have to add another step. So in other words, we always have to round up and then figure out the difference. So it's 16 steps, okay? So let's go ahead and clear this up. So now I know that if I'm going to go up 108, I have no zero here. They forgot to give me the zero. Let's see, it's 108, okay? But we divide that by 16 steps, gives us 6.75. So that means if every step is 6.75 of an inch, then and we have 16 steps, then we end up having, then we'll end up at 108 inches. We could reverse that math, right? 6.75 times 16 equals 108 inches. So that means that our risers needs to be 6.75 inches. If I have 16 steps, if I have 16 steps, how much length do I have? So 16 times 11, that didn't make sense. Let's see. 16 times 11, 176 inches. Now what is that? How much is that in feet? Well, we could divide that by 12. Right? Last time we multiplied by 12 because we want to go feet to inches. Now we want to go inches to feet. And that's roughly 14 and a half feet. That's how long of a distance you need if you want to go from one floor to the next floor, and if the floor height is 9 feet. Okay. I'm sure that people who are just starting off do not realize how much space, the length that an actual stair takes up. All right, so now we have our number, and that's the math. Okay, if you understood that, then you're good. This is probably one of the most complicated, mathematically complicated steps that most kind of that architecture and design really kind of takes up is figuring out steps. So if you got this, you're good. You're solid, right? All right, so let's go ahead and create our steps. So I'm going to create a step using the rectangle tool. And remember that the first number we enter goes along the red axis. So the first number is going to be 11 inches. Okay. And the second number is along the green axis. We're going to make that 3 feet. Okay, because that's a, oops, 11 inches, enter. And then 3 feet, enter, because that is the size of our steps. And then we're going to extrude curve, not extrude curve. Okay, make sure solid is set to yes. And we're going to go up 6.75 inches. Enter. Now I know what 0.7, I know that 0.75 is 3/4, but it doesn't always break up that way. Sometimes it'll be 6 point, I don't know, 6.78 of an inch. So then you enter that. Okay. And if you want to know what 6.75 is, we just measure it. Distance, enter. It's 6 3/4. Okay. So there we have our first step. I'm going to now copy this, go from one corner to the next corner. Now I could keep doing this over and over, but again, it might be just a bit faster if I can just turn all of these on. And now all I'm going to do is just click. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. Oh, I forgot that last one. Let's go one more. There we go. I think that's enough. Let's go ahead and delete this because we don't need that anymore. I'm going to move this off to the side just to make sure that that I hit where I need to go. There we go. So now we have our steps. Okay. I always build my steps outside of my model first. I never try doing it inside because you could see, I mean, you could imagine how difficult it would be to just get your camera in there and move around. So always build your steps outside of the model and then move them into place whenever you need to. Let's go ahead and move these out a little bit more. Okay. Now, the next thing that we need to do is actually the little stringer kind of, steps don't connect just at these corners, right? We need to provide the support that goes underneath. Now, we're not actually modeling the structure. We're just trying to create that visual representation of what it would look like. So I'm going to use polyline tool, and I'm just going to draw this triangle. 1, 2, 3, And there we go. And then I'll extrude curve. I'm going to bring that over to that side. And there we have that piece. Now with this one, I'm going to do the same exact thing. I'm going to copy this, go from this corner to this corner, and then turn all of these on. Oops. And then move my cursor. And then right there. And now what I'll do is I'll select all of the pieces. I'm going to union them together. So when I click, it's one solid object. Okay. And there we have that. Now I have that line. I could go ahead and delete this. And so there we have our set of stairs that is to code and that meets and that actually takes you from the first floor up to the second floor, and each riser height is the exact same distance. Okay. So next up, what we're going to end up doing is just finalizing the stair by creating the handrail, and then we'll go ahead and create the guardrail that's attached to the stair as well.